Welcome back to Speller Tutorial Services. Today we're going to talk about systems. In this particular example, we're looking at a system of two linear equations, and we want to find out where those two linear equations intersect, or even if they intersect. And we're going to do that algebraically. First, we see that in both of these equations here, we have two unknowns. And when you have two unknowns in an equation, you need to eliminate one of the unknowns to be able to solve the equation. In this particular example, I see that my x values, I have a negative 2x in my second equation and just an x in my positive equation. So to eliminate the x variables, I'm going to go ahead and multiply each one of my top terms by 2 so that when I combine these two equations, the x variable is eliminated. So let's go ahead and begin. Multiplying each one of these terms by 2 still leaves me with a true math sentence. So I have 2x plus 6y is equal to negative 4. And then I'm going to keep my bottom equation, which is negative 2x minus 7y is equal to 3. Now I'm going to combine these two equations to get rid of my x term. So 2x minus 2x is going to leave me with 0. No need to write the 0 down here. Then I have 6y minus 7y, which leaves me with a negative y. And then negative 4 plus 3 leaves me with a negative 1. We should never leave our variables with negative coefficients, so I'm going to divide both sides by negative 1. And that leaves me with y is equal to 1. Now I'm going to take this value for y and substitute that back into my second equation. I'm going to use my second equation because I made no manipulations on that equation, but it should work in either equation. First, let's go ahead and rewrite the second equation. Negative 2x minus 7y is equal to 3. And what I'm going to do is substitute the value of y into the equation. So I have negative 2x minus 7 equals 3. Going to add 7 to both sides, which leaves me with negative 2x is equal to 7 plus 3, which is 10. I need to get rid of the coefficient of negative 2 in front of the x, so I divide both sides by negative 2. Negative 2 divided by negative 2 simplifies down to just a positive x. And 10 divided by negative 2 leaves me with a negative 5. So the answer to my solution is negative 5, 1. At that coordinate is where the two linear equations intersect each other. Let's go ahead and do a check to make sure that our work here is done correctly. I'm going to again go ahead and start with the second equation because I made no manipulation. So let's go ahead and just rewrite that equation. Negative 2x minus 7y equals 3. Now we're going to do our substitutions. Negative 2 times x, we said was negative 5, minus 7 times y, which we said was 1. And that should evaluate to 3. Negative 2 times a negative 5 gives me a positive 10, minus 7 times 1, which leaves me 7. And I rewrite the right-hand side. Now I'm going to go ahead and evaluate the left-hand side. 10 minus 7 gives me 3. And I see that 3 does in fact equal 3. So I'm confident that I did do this problem correctly. Just to make sure, or just to give us a different representation or different view of what we've done, I went ahead and I actually graphed these two linear equations looking for the point that they intersected. And I have this in another program here. In this program, we see that the first equation, x plus 3y equal negative 2, is here as this blue line. And the red line is 2x plus 7y equals negative 3. What this program did was actually multiply each one of these terms by negative 1. So this here is actually equivalent to what we started with, which was negative 2x minus 7y equals 3. And here we see where those two lines intersect is at the point -5, 1. And if we flip back to our algebra, we see that -5, 1 is the location where these two linear equations intersect. So I want to thank you for watching another video by Speller Tutorial Services, either on our YouTube channel or on our Facebook page. Please stay tuned for more videos. Thanks.